in your right angle triangle, we now want to transition from thinking just about sides and how they relate to each other, and also considering how they're related to the angles inside your triangle. Okay? So for instance, I'm going to call this angle here in the corner, let's be fancy, because you guys are G1. I'm going to call it theta. Okay? So that's, I'll draw it for you again. It's a 0 with a tail in the middle, like that. Okay? They tend to use Greek letters for angles. I don't know why, because Greek's cool. Anyway. So I'm going to call that angle theta over there. Now, so far we've been calling these A, B, and C. C's been the important one. Okay? I want to shift your perspective on this a little bit and think about how would I describe or label each of these sides in relation to this angle that's important over here. Okay? Now the hypotenuse. We've already got a special name for that, so we'll just leave that be. Okay? The hypotenuse, always the hypotenuse. Okay? But now the other two sides I want to distinguish between them. Okay? Particularly in relation to the angle. Okay? So this is sort of my perspective. I'm standing here and I'm thinking about, well, how would I describe these two differently? Right? Well, this guy up here on the left, right? It's facing the angle. It's directly opposite, isn't it? Right? So I'm going to call this side over here the opposite side. It's opposite theta. Okay? Now what word can we use to describe this one that's down the bottom here? It's next to theta, so I'm going to call it adjacent, because the next to angle is true, but doesn't sound very articulate. So there you go. Okay? Now obviously if I change the angle, if I change my point of reference, if I went up here, what would change? They'd swap around, wouldn't they? Hypotenuse is still where it is, okay? But for this angle, this is opposite, and this is adjacent, okay? So this is 9G. This is exercise 9H. All you have to do is work out which one's which, okay? So you're like, really? We're senior students now, come on, okay? And admittedly, it's just a warm-up. It's just a warm-up for this next thing. I actually want you to make space for a subheading, but just leave it off for a second, okay? And we'll see if you can work out how long it will take you for you to work out what this thing is actually called, okay? Underneath your blank subheading, I want you to draw two right-angled triangles for me, but this time, I want you to draw them similar to each other. So for instance, you might draw one that's 3, 4, 5. You don't actually have to label them, but maybe you want to get a ruler out so you can actually have some measurements here. Okay? Your next one over, maybe we can make it 6, 8, 10. Okay, so this is two similar triangles. And we're going to talk about what's going on between the sides and the angles here. Okay? Wait for you to catch up a second with your drawing. Let's give these triangles some names. I'm going to call this one PQR, and I'm going to call this one XYZ. And you can see I've got a theta there in the corner. Okay. Now I think most of you are starting to catch up. Let's try just a few things about this. Okay. Triangle PQR is similar to triangle XYZ. What's our symbol for similarity? Do you remember? It's 3 lines. Which way do they go? Do they go horizontal or do they go vertical? They go vertical. The way I remember it is that if you got these across, that's telling you everything is equal about this, right? In fact, we call this the equivalence relationship. But clearly not everything is equal here, right? This guy's bigger, yeah? So it's close, but it's not every single thing. So that's how I remember that what's that? It's not similarity, it's congruence when you're talking about triangles. Right? So it's not that, okay? On the ball today. It's similarity. So triangle PQR is similar to triangle, we call it XYZ, okay? Now therefore we can say that, and I've already labeled it on there, right? Angle PRQ is equal to angle XZY. What would be the reason that you give for that? Like you'd actually say a reason over here. Starts with a big, long, awkward word starting with a C. Anyone remember it? Corresponding. Corresponding. Now I'm talking about angles, aren't I? Right? Corresponding angles in similar triangles. Goodness, this is long. Are equal, right? Good. Okay. So, and I've already put that in there. I'm just calling both of them theta. Okay. Now, have a look at these sides. I can make a statement about the sides of these triangles and how they relate, just like I can make a statement about the angles and how they relate, right? So for instance, let's have a look at this one. PQ, okay? Now, think back when we were doing this, right? In this little triangle over here, the small one, PQ, which side is it in relation to the angle? It's the opposite side, isn't it? And you can see it's sort of, it's looking all the way to the other side of the triangle, so it's opposite, okay? So PQ, if I divide that, I take the ratio of PQ over PR, which is the hypotenuse, okay? That ratio should be the same as another ratio in the other triangle. Which sides is it?
X, Y, Z.
Good. XY, which again is the opposite side, over XZ, which again is the hypotenuse, okay? Now, we gave a reason for this statement. What reason do we give for this one? It's close, but it's not quite the same. Still starts with corresponding. Corresponding, well, obviously it's not angles, it's sides, okay? It's still in similar triangles. Okay. So we've got a choice here. The first way you could say is they're in the same ratio. Are in the same ratio. Because what you've got here, here's a ratio, right? And here's another one, and they're the same. 3 over 5 sure is equal to 6 over 10, right? Another way you can say it, in case you don't like writing 3 words here, is you can say in proportion. Both of them are accepted in the HSC. They're both equivalent. Okay. Okay, now, remember we were making this big deal about opposite and hypotenuse and all that kind of thing, right? So what you've really got here is that opposite side over the hypotenuse. I'm just going to abbreviate because all these words are long. Okay, the opposite side and the hypotenuse in one triangle, right, is equal to the opposite side on the hypotenuse in the other one, right? Now I could draw another triangle, couldn't I? I could draw a third one, and a fourth, and a fifth, and a 500th. Okay, and if they're all similar, then all of these ratios are always going to be the same. Can we agree to that? Is that okay? So therefore, like, and what might the triangles be? It might be something like, oh, I don't know, 300, 400, 500, okay? The side lengths aren't what matters, okay? The side lengths can change whatever you like. You can make this triangle as big or as small as you like. What's the thing which really stays the same? What's the common feature between all of these triangles that makes them similar? It's not size. What is it? Now, scale's a tricky word, isn't it? I guess if you said scale with relation to each other, that'd be okay. But actually, the scale is really changing. You're getting small things and they're going into big things, right? I'll tell you what's the same. That angle's still going to be the same, right? Every single time, no matter how enormous you make your triangle, okay? That angle in the corner there is always going to be the same for this reason that we've set up here, right? So what really matters is not the side lengths, it's the angle, okay? It's so important, the angle, right, that we give these ratios names when you're talking about ratios and angles and how they go together. For instance, this one, opposite hypotenuse, does anyone remember what it's called? This is hard to remember. This one is sine. This one is sine. You're like, why did I start with sine? I'll tell you in a second why. This one we would call sine theta. Well, it's always the same angle, isn't it? Okay. Sine theta in all of these triangles is always equal to 3 over 5, so long as theta stays whatever it is. I don't know, it looks like about 42 degrees or something like that. Okay. No matter what triangle you're in, it's always equal to this ratio, so long as the angle is the same. Okay. Now, that's opposite on hypotenuse. Opposite on hypotenuse. hypotenuse. The other ratios are also important, and there are three sides, so you have three ratios, three ways to pair them up. Opposite on hypotenuse, I can do the adjacent side, that's this one, right? The adjacent side over the hypotenuse. Okay, does anyone remember what that one's called? Starts with C. It's cos. Well, it's short for cosine, but we're always looking for a shorter way to write it. Okay, so in these triangles, it'll be adjacent over hypotenuse 4 and 5, right? In this triangle that we've got. Okay, and there's one more that we look at, one more combination of these, which is the opposite side over the adjacent side. So forgetting about the hypotenuse for a second, and we call this one tan, which is short for tangent. Okay. What is it in this case? It's opposite over adjacent, so it's 3/4. Okay. You may notice as well, 3/4. That's the same as saying sine on cos. Can you see that? This over this gives you 3/4. The 5s cancel out. Okay. So, I admit, it is pretty hard to remember, and you're like, why are we introducing all this new language anyway? So there's a mnemonic, if you've learnt it, if you've heard of it before, called SOHCAHTOA. Hands up if that's familiar to you. Yes? Good. Okay. So sine goes with opposite on hypotenuse, right? Cosine goes with adjacent on hypotenuse. Tan goes with opposite on adjacent. And there you go. Okay, by the way, what should we call this subheading? I could call it SOHCAHTOA, but that's kind of a tool to help you. What is this really about? These are called the trigonometric ratios. Now, just think about that for a second. Obviously they're ratios, because that's what we've been talking about the whole time. Right? Ratios comparing two sides, how big one is versus the other. They're called trigonometric ratios. Well, we know what metric means, right? Metric just means about measurement. That's why we call our measurement system the metric system. What's this thing? What's a trigon? We don't talk about trigons very much. We're usually more familiar with their more common friends, polygons, right? Many angles, 3 angles. So these are the ratios to do with measuring triangles. Crazy backwards English people, but anyway, there you go. Okay, so that's the heading you can put over all of this.